In 2012, Carly Zakin and Danielle Weisberg founded The Skim from their couch. Now, 6 years later, their morning newsletter gives over 7 million subscribers the news and information they need to start their day. And when they first started the company, they got a lot of advice from other female entrepreneurs. And now they're sharing those conversations and more on their podcast, Skimmed from the Couch, SKIMM' from the couch. Every week, you'll hear from women like Ariana Huffington, founder of the Huffington Post and Thrive, on why she puts her phone to bed at night, or Melanie Whalen, CEO of SoulCycle, on why she has a millennial mentor, or how actor Taraji P. Henson got over her first rejection and learned how to negotiate for herself. It's a podcast about the real stuff, tips and tricks to launch, grow, or change your career. The only rule on the couch, no BS. And check out Skimmed from the Couch wherever you listen to your podcasts.
9.
T-minus 8 seconds. 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff.
Welcome back to the Space News Podcast, all you space cadets out there. I want to take a couple seconds to thank everybody who's been visiting our website at spacenewspodcast.com and everyone who's joining our Discord, Twitter, and Facebook. I want to say thank you to everybody who's been supporting this podcast, giving us good ratings, and just listening to the podcast helps a ton. So thank you so much for all of your support. I really do appreciate it. Have you ever felt like you want to travel into the future? Well, just recently, a paper has revealed that matter that's been sucked in by black holes may travel into the future and then get spit back out into the present. Black holes are the most mysterious places in the universe. There's data on them. No one's ever seen one per se. No one's ever taken a picture of a black hole. And they're locations where the very fabric of space and time are warped so badly that the speed of light is too slow. Light cannot escape a black hole. And according to Einstein's theory of general relativity, at the center of black holes lies a singularity, which is a place where the mass of many, many, many stars are crushed together into a volume with exactly zero size. There's two recent physics papers published on December 10th in the journals Physical Review Letters and Physical Review D, and they may make scientists reconsider what we think we know about these mysterious monsters out there in the universe. And according to these papers, black holes might not last forever, and it's possible that we've completely misunderstood them and their nature and what they look like at the center. So astronomers and physicists, they've held the idea of a singularity that simply must be wrong. And if an object has mass and it has no size, then it has infinite density. And as much as researchers throw around the word infinity, infinities of that kind don't exist in nature that we know of. And when you encounter an infinity in a real physical science situation, what it really means is that you've pushed your mathematics beyond the realm where they apply, and you need to make some new math. So let me try to explain this a little bit. So if you have an object, say we have like a tennis ball, right? Everyone knows what a tennis ball is. And say if it's located far, far, far from Earth, it would have a certain weight. Then as you brought it closer to Earth, the weight would increase. And taking that equation to the extreme, as you brought the object near to the center of Earth, it would experience an infinite force. But it doesn't. If you bring that object close to the surface of Earth, Newton's simple law of gravity no longer applies. You have to take into account the actual distribution of Earth's mass, and this means you need to use different and more complex equations that predict different behaviors. So Einstein's theory of general relativity predicts that a singularity of infinite density exists at the center of black holes. But that can't be true. At very small sizes, a new theory of gravity must start, right? We have a generic name for this, and it's called quantum gravity. This basically just means gravity at the smallest scales in the universe, and the phrase doesn't really imply a specific theory. Its specific theoretical proposals have been made that would describe gravity as it is in the microcosm. One proposal is called the loop quantum gravity. So there's two scientists from Pennsylvania State University, Abhay Ashtekar and Javier Almeida, and Parampreet Singh, sorry, my bad, I butcher names, at Louisiana State University have applied loop quantum gravity to the center of black holes, and they claim that the result is not a singularity like we once thought. They calculate that space-time is curved strong near the center of the black hole. And the result is that space-time continues into a region in the future that has the structure of something known as a white hole. And a white hole is like a black hole in reverse, meaning that unlike a black hole, which pulls matter in, the white hole shoots the matter out. And there is perhaps another way to imagine what they're predicting. It's known as strong gravitational fields, and that's when time slows down. As far as we know, black holes contain the strongest gravitational fields in the universe. And because of this, a possible interpretation of this new work is that matter falls into a black hole and then bounces. And it shoots the mass back across the cosmos because time is so slow near the center of the black hole that the process simply is taking an enormous amount of time. And if the researchers are right, in the very distant future, where there are now black holes, matter will be erupting, spreading matter throughout the cosmos. So basically what happens, okay, matter goes into the center of a black hole. It speeds up through the timeline. And in the future, this same matter shoots out. And these things have been kind of observed. You know, these weird things have been kind of observed by scientists before. There's very high energy phenomena in space that haven't been explained. And one of them is the existence of very high energy cosmic rays that actually hit the Earth's atmosphere. Another is what called fast radio bursts, which is when a large amount of radio energy is observed in a very short amount of time. So they could, in principle, be the signature of a black hole transitioning into a white hole. The matter that went in could be popping out in the future. That's what these bursts could be. That's a theory. These are theoretical physics that we're talking about here. These aren't set in stone. And with all theoretical physics, there has to be a lot more testing done. There has to be a lot more engineering with these principles. So take it for what it is right now, which is a really cool thing. It's a really cool theory. And in the future, hopefully we'll know what's going down with this stuff if we can get some more scientists involved with this. Could this be a way for us to time travel into the future? I mean, if you go to the future through a black hole, of course you're going to get spaghettified. And of course you'll get destroyed. But it's a way to send matter through a black hole, pop it out of a white hole, and go into the future. Just think about that for a second. Is time travel possible? This may be time travel. I'm just saying, this is pretty cool. Now, you know what else is cool? Oh, you guys. Oh, look at that transition. I'm so good at that. Now, I want to say thank you for everybody who supported the podcasts and all you time travelers out there that are listening. Thank you so much for all the support. I really do appreciate it. Thank you so much for subscribing to the podcast. And thank you so much for donating, hitting us up on Discord, on Twitter, on Facebook. You can go check us out at spacenewspodcast.com. Thank you again, everybody, for tuning in. My name is Will, beaming this directly down from the mothership. And I will see you soon.